Hello and welcome to episode 8 of our series Back to Basics, Season 2. We've seen many topics about utilization of data in an automatic or more machine approach. Today we are going to talk about data mining and data science, two very cool topics that we will explain right now. From Wikipedia, data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data, and apply knowledge and actionable insights from data across a broad range of application domains. Data mining is a process of extracting and discovering patterns in large datasets involving methods at the intersection of machine learning, statistics, and database systems. Let's start with more details on data science. As said, data science is this field focused on extracting knowledge from datasets, which are typically large, and applying the knowledge and actionable insights from data to solve problems in a wide range of application domains. The field encompasses preparing data for analysis, formulating data science problems, analyzing data, developing data-driven solutions, and presenting findings to inform high-level decisions in a broad range of application domains. As such, it incorporates skills from computer science, statistics, information science, mathematics, information visualization, data integration, graphic design, complex systems, communication, and business. People are today linking data science to human-computer interaction. Users should be able to intuitively control and explore data. In 2015, the American Statistical Association identified database management, statistics and machine learning, and distributed and parallel systems as the three emerging foundational professional communities. Big data is very quickly becoming a vital tool for businesses and companies of all sizes. The availability and interpretation of big data has altered the business models of all industries and enabled the creation of new ones. Data-driven businesses are worth $1.2 trillion collectively in 2020, an increase from $333 billion in the year 2015. Data scientists are responsible for breaking down big data to usable information and creating software and algorithms that help companies and organizations determine optimal operations. As big data continues to have a major impact on the world, data science does as well, due to the close relationship between the two. The main fields of application for data science are in various areas, such as fraud and risk detection, healthcare, targeted advertising, website recommendation, advanced image recognition, and many others. An essential tool for data science is an efficient data cataloging approach. A data catalog is an organized service that allows users to centralize the descriptions of the available data sets and learn more about their data sources, which help organizations achieve more values from their assets. Advantages to centralizing metadata are mainly the consistency and accuracy across department, government, a better data congruency, quality and structure, an easy access self-service architecture. Depending on the objective of the project, cataloging will allow automatic crawling of metadata describing the various data sources like census, social networks, or others, integrating the metadata into a centralized catalog that shows what data assets you have and where they are located. In the context of applied intelligence, it will enable users to analyze and prepare the dataset found in metadata catalog, defining business rules, terms, policies, and ownership. Finally, helping reimagining the business processes, It will help manage access to datasets, semantics, and collective knowledge to publish the enriched dataset to the catalog for the other users like data scientists or data engineers. Adopting data science in an organization requires a well-defined methodological approach. Even if this should be elaborated on a case-per-case basis, we can point to 6 major steps to go through. Ask an interesting question. Whether it originates in the mind of the investigating data scientist or as a request from other parties, every inquiry starts as a question to be answered. The main one being, is there a business goal to achieve? Design a data collection program. In many cases, data scientists work with existing datasets collected during other investigations. But the way that data is gathered and stored can limit the questions that may be answered from it, and relevant data is not always immediately available. With the question in mind, the data scientist will decide how to gather the information required to answer it, establishing whether or not the data exists in the real world and is relevant to the question, devising a collection scheme to acquire it, taking care of logical considerations, costs, and privacy issues, and coordinating with departments or agencies needed for collection program liaison. Collect and review the data. Even the best designed data collection system will result in some quirks and oddities in the data as it actually becomes available. Typos, falsification, or frequently misunderstood questions on badly designed forms can all present data sets that are less than factual. As the data is collected, the data scientists will review it and revisit the collection program and get a feel for the set, storing the incoming data in a way that will allow further modeling and reporting, joining data from multiple sources in a relevant and logical manner, and checking for anomalies or unusual patterns. Process the data. Either due to anomalies found in step 3 or just the general and common necessity of cleaning up messy raw data, the data scientist will have to wrangle it before moving further into the modeling process. Also known as munging, this hard to define step is one of the ways that data scientists make the magic happen, bringing skills and intuition to bear to take messy, incoherent information and shuffle it into clean, accessible sets, deciding on the tools to use to comb through the raw data, tools like Python, R, or SQL, and storing the mung data as a fresh data set, or use programmatic pre-processing for each subsequent query. Model and analyze the dataset. With all the important groundwork complete, the data scientist will get down to the fun stuff, diving into a clean data set and applying the pick and shovel algorithms that will pluck meaning from it, building a data model to fit the question, validating the model against the actual collected data, performing the necessary statistical analysis, performing regression testing and other classical statistical analysis techniques, and finally comparing results against other techniques or sources. Visualize and communicate the results. The most challenging part of the data scientist's job is taking the results of investigation and presenting them to the public or internal consumers of information in a way that makes sense and can be easily communicated, graphing or charting the information for presenting, telling a story to interpret the results, and assisting decision makers in using the results to drive their decisions. This 6-step process is rarely linear. Each step can push a data scientist back to previous steps before reaching the end of the process, forcing them to revisit the methods, techniques, or even reconsider whether or not the original question was the right one in the first place. And having finally come to a definitive result, the data scientist will almost always find that the answer simply sparks more questions. The process begins again. Sometimes it might be confusing to some people to distinguish between data science and data mining. While data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structured and unstructured data, data mining is a process of discovering patterns in a large data set, involving methods at the intersection of machine learning, statistics, and database systems. Even if data mining existed before the concept of data science, data mining is often considered today as an interdisciplinary subfield of data science, with an overall goal to extract information with intelligent methods from a data set and transform the information into a comprehensible structure for further use. Data science is related to data mining, deep learning, and big data. For example, retail companies and the financial community are using data mining to analyze data and recognize trends to increase their customer base, predict fluctuation in interest rates, stock prices, customer demand. The role of a data science professional can be considered as a combination of an artificial intelligence researcher, a deep learning engineer, a machine learning engineer, and or a data analyst to some extent. The person might be able to perform the role of a data engineer as well. Therefore, data science often requires a team of skilled profiles, while a data mining professional doesn't necessarily have to be able to perform all these roles. While the field of data science concentrates on the science of data, the field of data mining is mainly concerned with the process. Therefore, data mining may be seen as the analysis step of the knowledge discovery in databases process. The term data mining is a misnomer because the goal is the extraction of patterns and knowledge from large amount of data, not the extraction or the mining of data itself. The actual data mining task is the semi-automatic or automatic analysis of large quantities of data to extract previously unknown, interesting patterns such as groups of data records for cluster analysis, unusual records for anomaly detection, and dependencies. These patterns can then be seen as a kind of summary of the input data and may be used in further analysis or, for example, in machine learning and predictive analytics. For example, the data mining step might identify multiple groups in the data, which can then be used to obtain more accurate prediction results by a decision support system. Now that we know a little bit more about data mining and data science, let me thank you for watching, and I will see you on the next episode, which will talk about enterprise performance management. See you soon.